Hello and welcome to part 3 of this little series of pumps in PEL. So part 1, we looked at this little sketch and we looked at a single flow rate and what that pump needs to do, what delta P across the pump is. Part 2, we looked at the actual system curve. So we looked at what delta P that pump needs to do as flow rate changes. And now what we're going to need to do is add in our pump. And how would we start to do a pump curve using the PEL suite? So I'm going to click on my tab pump curve here. You can see I've got a little table already set up, and this defines my pump curve. Not particularly useful as a 5-minute short. There you go, it's done. So how did we do this? So I use a little graph reader. And where do I find the graph reader? If I go to my little PEL menu, there we go. I come back up one. It's under Tools, little graph reader button here. So that's how I got to the graph reader. And if I bring it across, it looks like this. So all I've done is I've taken the snip from a catalog. So I've got a variety of pumps, as you can see. And then first thing we need to do is set the extents. So I'd press reset the extents. So we need to do that on the graph. Now, this is in some interesting units, but I want to really keep it in the good old-fashioned units because it makes sense. 125 gallons. So we're going to set these extents, and we're going to stick in US customer units at the minute. And that was quite a bit of fun. Gallons per minute. Is that a UK gallon per minute or a US gallon per minute? A little bit of jiggery pokery, I worked out that was a US gallon per minute. So not all gallons are the same. That's one for the kids, that one. What is a gallon is a good question. We have not got time for that. Right, we've set the extents. We've set this to 125 Y max, Y min 0. The unit in feet doesn't make a huge amount of difference at this point, but let's sort of try and keep things right. It would make a difference if we're using this tool in FlowNet. And then again, we've got 0, we've got 400 in here, and then I'm just going to start clicking along this particular pump here. So I'm randomly selecting a 3521 pump, and with a little bit of accuracy or not, we're going to put some points along that. And you can see I've managed to click 14 points, and if I click that, you can see them there, and we will need that, or that's what I used for creating the curve in Excel. So I can create those points, I can copy and paste them across. This little red line though is the interesting bit. So what this little red line has actually done is it's created a polynomial, a line of best fit. And we can change what that polynomial does down here. So I can start changing that to one that kind of looks about right. It's looking after, is it 7, is it 8? When I originally did, I went for 8. And that creates our equation in here. Now, obviously, normally you do these things in things like Excel, that would say X. So you've got, a number, something to the X, and then there'll be something to the X squared, etc., etc., etc. That's not particularly useful for working in Excel. So what we've done in here is, well, actually, where do I want to calculate? I want to put my flow rate in, and I want to calculate that head, and I want that equation in there. So my X value is E57. So I've gone into here and I've written E57 in there. I can press copy, come out of there. If I was going to do it in here, I could paste it in there. So that's going to just give me that big number, but I'm just going to put equals at the start. And then lo and behold, I'm off and running. Slightly different values. I've done this slightly differently and done a more points, slightly different correlation from last time. Oh, thereabouts. But that's how I managed to get that equation in nice and simply using the equations. Now, again, US gallons per minute, feet, not our natural habitat. And previously we were using meters cubed and meters, not too unreasonably. So I wanted to create that values there. And again, what I've done, instead of just like remembering how do I convert US gallons per minute to meters cubed an hour, and no, I don't know what the conversion is for that. So despite my advancing ages, so again, I've been using the Capri functions. So if we go back to Capri, insert function, and then what this one is, this is a convert function, convert value, and they pull it all out here. But you can just pick this up and put it into your table. So you can see it's looked at the old units, the old value, the old units, new units. Actually, for molecular weight, that's because sometimes it plays about in volumetric terms. Just put that as naught. In this case, it's irrelevant. So you can put that in naught, and then it will give you the value. So that's the way we did these flows here. And the head, similarly, I've converted that head from feet into meters to create a little table. And we can graph that if you want to graph your pump curve. So we can graph that. But what we really want to do now is actually think about, where does our pump curve meet our system curve? So if I go back to my system chart, the last one of these, we drew this system curve. This is my pump curve, and we can start to see where our duty point is going to be. And as we change K values, whatever it is within the system, change the liquid height, we can start to move that curve around and see how it affects the position on that pump curve, the flow rate through the system. Now we need to find this point. This point is interesting. We'll want to put that on things like data sheets. So what we've done here, instead of sort of again squinting at this and thinking, well, where is that point? What I've done here is I've taken a line of best fit of this value. This line, this is my system curve. I've got my trend line. And you'll see it's a polynomial. So I've set a polynomial up. I've asked it to display the equation and the R squared on the screen. And then what I also did was, I can make this work, format the trend label. I've said it's a number, and you want a lot of decimal places. You need to pick up those decimal places, otherwise you don't get a very accurate representation of your line. And then you can select all this and copy it. You can select all this and copy it. And then once we've done that, what I've done is gone to my system curve. So right down the bottom here, I've now got two curves. So that's my system curve that we've just seen. I've also got a pump curve, a pump equation. So for a particular flow, I can work out what the head is on that system curve. For the pump, for the same flow rate, actually convert into US gallons to go to feet to meters. And then what I can do is try and make these two values the same. So if I completely take off my flow and say, oh, I'm going to get initial guess of 12, I've got a little goal seek here. So what I'm doing here is I'm dividing that head by that head. They should be the same number. So I'm going to again use the wonders of Excel, goal seek. I want that value to be 1. I want to change my flow. That will change until those two numbers equal the same, 23 meters cubed an hour. If we look at this, about 23 meters cubed an hour, we're in the right place. We've now discovered our duty point based on our pump curve and our system curve. And part 4, we'll have a look at the rest of the pump. Hope that was useful. Thank you very much.